What's happening? कैसे हैं आप? How are you doing on this awesome Saturday evening? Yeah, we are live to you with more of electrochemistry. Nernst equation की बात करेंगे. Nernst equation is very useful. But what's the idea behind the Nernst equation? एक थोड़ा कुछ लोगों को इससे डर लगता है. Don't worry about it. It's linked to thermo for sure. If you're cool with thermo, whoops, then you'll be cool with this. If you're not cool with thermo, don't worry. I'll get you cool with thermo. That's my job, right? These are topics that I really like. Physical chemistry is my jam. So I've got you covered all the way. All right. What's up? Kirti, Aditya, Varad, good evening, good evening, good evening. I'm guessing you can hear me and see me, right? Narayan Das ji, hi. I want to talk about something right in the starting though. There was a question in the last session that we did, जिसको मैंने आपको ठीक से नहीं बताया. What is that? That's that. Huh. There's something that's there. Okay, it's bugging me. Anyway, we'll figure it out later. So, last session, I told you the answer to this question, and I said very confidently to you that the answer for this is 4. But that was not correct. So, the first thing I want to talk to you about is besides 1, 2, 3, and 4, there are other elements that also obviously react with steam. I mean, you know the answer to this. आप अगर 10th स्टैंडर्ड में भी ये चीज पढ़ चुके हो कि देखो रिएक्टिविटी सीरीज कैसे बनाते हो, जो पानी के साथ रिएक्ट करेगा दैट्स ग्रेट, और राइट ऑन टॉप जो स्टीम के साथ रिएक्ट करेगा उससे थोड़ा नीचे, एंड जो स्टीम के साथ भी रिएक्ट करे उसके नीचे, राइट? रिएक्टिविटी सीरीज, इलेक्ट्रोकेम सीरीज इज आल्सो लाइक दिस, बट दिस इज वेयर थिंग्स गेट इंटरेस्टिंग. ओके, द रीजन बिहाइंड these reactions is a little bit different from the others. Okay, there are complex formations happening. There are things that will be clear to you when we do coordination chemistry and when we do D block elements. Okay, I know this is a P block element, exception to the rule, but rest of these are all D block elements, and the reason why it reacts with water is not that direct. So I can't tell you the reason just based on the electrochemical series. Okay, so this was not a question that should have been there in this chapter, so that's on me. The answer to this is 9 and not 4. Trin from Discord, thank you for pointing it out. That was a really great discussion we had. All right, so you're able to see me and hear me, right? I feel like you're all saying good evening. That's great, but मेरी आवाज आ रही है, right? Like on a live session you just have to be sure that everything is clicking right, and कभी कभी होता है नहीं होता है, तो yeah, all right, it's all good. चलो ठीक है, एक और सवाल करते हैं. We'll start this session off with a couple of questions. Session off. Which of the following ions does not liberate hydrogen gas on reaction with dilute acid? This is easy, right? This you can use the regular whatchamacallit, जो आपका electrochemical series. This is not a complicated question at all, but the answer could be, एक आंसर हो सकता है, एक से ज्यादा भी हो सकता है. I have misplaced something. I found it. Yeah, it's a fun Saturday for you and for me. So, how do you do this question? आपको इसका मालूम है? Hey, Hare Krishna Yusuf. Can we solve this question? Which of the following ions does not liberate hydrogen gas? Oof, how do you do a question like this? Do you want the electrochemical series like in front of you? We'll do that. NCRT electrochemical series. It's all right, And for the first couple of times, as long as you need to take to get comfortable with this, open up the electrochemical series. It's okay. Yeah, it doesn't matter so much. I know you don't have to mug it, obviously, but just to get an idea of what's going on, right? It's fine. It's all right. कोई चक्कर नहीं है. Hold on. Let's go with this. Let me show you this. All right. Here it is, the electrochemical series in all its glory. All right. हाइड्रोजन के नीचे कौन से हैं? सॉरी, हाइड्रोजन के ऊपर कौन से हैं? हाइड्रोजन के ऊपर I've got नीचे, sorry, not ऊपर, नीचे. Okay, because it's okay. So I've got lead, I've got this, I've got nickel, I've got Fe, Cr, Zn. Okay, out of all of these, ये सब तो हैं, इसमें कौन सा नहीं है? Which is not here? Oh, none of these. Chromium वहां पे था, तो it's not going to be the answer. Titanium, vanadium and manganese. Let's look that up. Titanium, vanadium, manganese. इसमें तो कुछ भी नहीं है. इसमें NCRT में तो है ही नहीं है. Do we need a bigger series? I think we need a bigger series. Chromium, yeah, okay. Aditya, yeah, the Joker, professional Joker. Narayan Das, all good. A, Varad says A. I think Varad got the answer. But this is the weird thing. ये NCRT में नहीं है. We'll need a bigger table. Okay, let's get the exhaustive. I don't know if it's even possible. Exhaustive electrochemical series. जिससे हम लोग ये आंसर निकाल सकें. Yes, I want to leave the side, boss. Already, everything I'm typing in. Exhaustive. PDF files for exhaustive electrochemical series. Oh, the BYJU'S site has one. Okay, all right. Well, I'm not plugging in BYJU'S randomly. It really does. But इसमें है क्या? नहीं, ये भी NCRT वाला ही है. What I see over here. Do you guys have a series जिसमें manganese है? खैर, well, don't take my word for it. Find the E0 values. Yeah, Aditya, you're right. Wait for the next 10 minutes and maybe we'll do a halftime, like there's a halftime show in football and basketball. You can be that halftime entertainment for us in our class. How about this question? Yeah, A is the right answer for that one. Okay. I know, I thought that I'll give you the data for this, but that's a little hard one. Let's do this one. For the reduction of NO3 minus, this is logic. This is complete logic. Don't worry, कुछ मग करने की जरूरत नहीं है. All right, Aditya, we'll wait. Wait, breath. For the reduction of NO3 minus in an aqueous solution, E naught is 0.96 volts. Values of E naught for some metal ions are given below. कुछ metal ions के दिए हुए हैं, okay? And I've got to figure out the pair of metals that is or are oxidized by NO3 minus. कौन से oxidize होते हैं? निखिल भाई क्या हुआ? लिख के रिट्रैक्ट कर दो, सब ठीक तो है आपके साथ? What do you think about this? हम लोग जानना चाहते हैं कि नाइट्रेट आयन किसको ऑक्सीडाइज करेगा, मतलब नाइट्रेट खुद रिड्यूस हो रहा है. ओके, ऑलराइट, दैट्स अ हिंट, दैट्स द बिगेस्ट हिंट यू नीड. सो इन दिस प्रोसेस you basically have well, nitrate at the reduction end, which means the cathode पे होगा और anode पे होगा anything else. So you have to reverse the anode reaction and you have to keep the cathode reaction as it is, add them up. If you get a positive E naught value, awesome. If you don't, well, that reaction is not happening. It's not going to happen. That's it. That's simple as that. ठीक है, cool. All right, please try it out now. With that input, I think कोई भी कर लेगा, है ना? चिल है अभी तो, कर लोगे ना? What do you think the answer is? This one has more than one correct. It definitely has more than one correct. That's my hint to you. Yeah, no doubt whatsoever. एक से ज्यादा सही है इसमें. ठीक है, try करो. क्या हुआ? Okay. So if you want to write down what I'm saying, E naught. Where's the pen? Here's the pen. E naught is 0.96 volts. That's the cathode. Okay. Anode मतलब इसको नेगेटिव करो, इसको नेगेटिव करो, you should get a positive one. Now obviously if I just the first one I see ये वाला नहीं होगा, gold नहीं होगा, because E naught of 0.96 minus 1.40 is a negative number. That's not happening. This 0.96 minus 0.86, 0.1. Awesome, this works. This, yes, this becomes 1.0. Okay, this works. This one is the best. This becomes 2.59. Wow. वाओ, सो वेनेडियम को तो डेफिनेटली भाई साहब रिड्यूस कर रहे हैं, वेनेडियम को डेफिनेटली ऑक्सीडाइज कर रहा है. या सो दिस गाय गेट्स रिड्यूस एंड इट ऑक्सीडाइजेस द अदर ऑफ देम. सो गोल्ड के अलावा एवरीथिंग एल्स इज बीइंग ऑक्सीडाइज्ड बाय नाइट्रेट. सो जिस ऑप्शन में गोल्ड नहीं है, दैट्स गोइंग टू बी द आंसर. दैट वुड बी ए, बी एंड डी. हे, व्हाट हैपेंड टू यू गाइस? दिस वाज एन इजी वन. जोक क्रैक नहीं कर सकते बट आंसर तो दे सकते हो. क्या हुआ, इतनी जल्दी भाग गए तुम लोग? ठीक है. This is how you do a question like this. Okay. And yes, Mehak, D is correct, A is correct, and B is correct. All three of them are correct. सिर्फ गोल्ड ऐसा है जो ऑक्सीडाइज नहीं हो सकता है, क्योंकि गोल्ड का रिडक्शन पोटेंशियल बहुत पॉजिटिव है, तो वो भाई रिड्यूस होना चाहता है. इट डज नॉट लाइक गेटिंग ऑक्सीडाइज इवन बाय नाइट्रेट. इट्स नॉट पॉसिबल. आई नीड समथिंग स्ट्रॉन्गर देन नाइट्रेट टू डू दिस. Maybe we'll have to use fluoride or something, yeah, to oxidize gold. All right, chalo, let's talk about today's focus, right? The IUPAC representation of cell. And once we do this, then Nernst equation भी इसके बाद logically आगे आ जाएगा. What is the IUPAC representation? Does it have anything to do with IUPAC from I don't know, from organic chemistry? Well, not really. What we're going to do here is, अभी तक मैं आपको बोल रहा था वही से हम लोग लिख लेंगे. Cathode होता है reduction, anode में होता है oxidation. So what we'll do is we'll first write this chap right here. हम लोग पहले लिखेंगे anode half. We'll follow that up with the salt bridge, and then we write the cathode half. That's it. That's pretty much what we're going to do. Okay. So this is the notation. Left side में होगा anode half cell, right side में होगा cathode half cell. If you have any doubt on this, please pause me and ask me. But I think this is something you are familiar with. But we need to go over this. This is important. Okay. What is the meaning of this vertical line जो आप बीच में देखते हैं? That is a separation of two phases. I'm not saying two states. I'm saying phases. phase और state में फर्क होता है. Phase, same state में दो अलग phase हो सकते हैं. ठीक है. This is something you learn in materials when you look at अगर आप materials engineering करोगे, if you do metallurgy, any of that, you will see that it's possible for the same state, solid state, to have many different phases. अभी हम लोग उसकी बात नहीं कर रहे हैं. At our level, we can consider the aqueous phase to be different from the gaseous phase, different from the solid phase. In that case, सब state ही हुए. ठीक है. But मैं बता रहा हूँ कि इसका मतलब क्या है. इस लाइन का मतलब phase को separate करने वाली line. ठीक है. Okay, cool. Now I'm going to have anode on the left hand side, okay, cathode on the right hand side. Okay, cool. Notice that anode को मैं जैसे reaction हो रहा है exactly वैसे लिख रहा हूँ, which means cathode को वैसे लिखेंगे. See, anode में क्या होता है? Oxidation. यहाँ होता है reduction. So oxidation मतलब Zn gives you Zn2 plus, okay, and cathode is Cu2 plus 2Cu is being reduced. All right. What's in between is a phase boundary. इसका मतलब क्या हुआ? You remember when you had this looks like a very blurry diagram, but this is what but it's not that blurry, right? What it's trying to say is, see, this is the zinc rod, okay, or zinc rod जहां पे right where it is in contact with the solution, right? That is the phase boundary. वहां पे exactly. You remember the last session मैंने कुछ molecules draw किए थे, right, at the boundary. That's what this is. Okay. Similarly, copper के side में भी यही चीज है, right? You've got the solution where जहां से contact हो रहा है, where the contact's happening, and that is the phase boundary. That's where the reactions happen. That's why the phase boundary is important, because all reactions happen at that boundary. Okay, because that's where solid is available. So oxidation also happens from there into solution. Reduction also happens onto it. Cool. Okay, cool. If you have more than one material in the same phase, you separate with comma. इसका क्या मतलब हुआ? See, this is the example of a special kind of a half cell. We'll look at the different kind of half cells soon after this. Okay. Maybe I've got एक solid. उसके बाद मेरे पास दो different types क्या होंगे? Two different types of ions. Okay. I will separate them with a comma, which means that they are in the same phase. Okay, that's it. All right, sweet. Okay, now if you have other identifying information like this is a concentration, this is the pressure of the gas, this is a concentration, you will put that in brackets. So now the whole picture looks like this of half a cell. Okay, I write the state or the phase over here. Yeah, the phase boundary. उसके बाद aqueous मतलब पानी में dissolved है, 1 molar. This is how you write it. Cool. All right. The salt bridge, two dashes, anode half cell, cathode half cell, बीच में salt bridge. खत्म. This is the overall representation of the cell. This is the IUPAC nomenclature, which means you have anode on the LHS and RHS पे cathode. And although this is important for E naught, you always write, you can write anything, but usually you write E naught reduction of cathode minus E naught reduction of anode, right? Up anode react up you will write the reaction that is actually happening. What is the actual reaction happening? Zn plus Cu2 plus gives you Zn2 plus Cu. Okay, so the actual reaction is this and this. So you will write what is actually happening irrespective of how you calculate E naught, because to be honest you can find E naught multiple ways. I can also write this. I can write E naught oxidation of anode minus E naught oxidation of cathode, right? I could also write E naught cathode reduction plus E naught anode oxidation. They're all the same thing. It's just mathematical jugglery. Okay, cool. Any doubts? Just give me a thumbs up if everything is good so far. What we're going to do after this is interesting. It's interesting. ठीक है, anode cathode दिखा दिया आपने. Salt bridge is right in the middle. Cool. And if you've got a gas electrode, all right, good, Bharat. If you've got a gas electrode, what is a gas electrode? Oh, you remember SHE, standard hydrogen electrode? There you had H plus being reduced and वो दे रहा था आपको gas, H2 gas. What do you do there? Let's see. This is a little bit weird, but it says, I'll tell you, it'll make sense. It'll make sense in literally 30 seconds. We're saying that the gas is indicated after the electrode when it's in anode and before the electrode for cathode. इसका मतलब क्या है? देखो, this is because for anode, what is the reaction happening? H2 gives H plus. But where is H2? H2 is going to be at the electrode itself. So what we're trying to say is these two folks are together. Okay? Which means the platinum inert electrode is where the gas is going to either be evolved, or at the platinum is where the gas is going to react and give you H plus. That is why they must be together. Don't worry about this definition so much. Yeah, this may be confusing, but when you look at it like this, when you look at it, look, hydrogen has to react on the platinum. Platinum, you know, is a very good catalyst. Okay, it has pores on it जिसके ऊपर hydrogen आके react कर सकता है. Cool. And that's one part of it. So you will write platinum followed by this or this followed by platinum. How do you figure this out? Because the other part of this is, see, here oxidation is happening, which means the reaction is this. Or TK, you can also write it like this. Half H2 gas gives H plus aqueous. Right, could do that. Or there's reduction happening. So you will write it first. That's it. Figure it out from logic. Okay, please don't try and mug this. It gets very, very scary. Otherwise, look at this. It's kind of huge, isn't it? You're like, bro, what is this? ये देख के तो आदमी डर जाएगा. ये क्या हो रहा है, right? But this is because you've got at the anode, you've got the SHE, the standard hydrogen electrode. At the cathode, you've got copper. That's it. All right. What this is going to do is this will give you a positive 0.34 volts E naught value, which is the E naught reduction of copper itself. Okay. Everything when it's in standard states. What is standard state? 1 molar concentration, 1 bar pressure. Then, agar standard states pe hai, then you say E naught. But what if it is not in the standard state? That is what Nernst equation is all about. Agar standard state pe nahi hai, so how do you figure out E value? That's interesting. And this is beautiful. You'll be like, oh, that's it. That's all it's going to be, because it's literally an extension of this one equation. You remember this from equilibrium? Yeah. All we're going to do, we will write this as NFE. We will write this as NFE naught, and we will write this as, we'll substitute. This is the Nernst equation. This is it. This is the Nernst equation. There's nothing complicated at all about this. Yeah, it may sound complicated, but it's not. So look at it from this point of view. Okay? Be careful that one of these signs becomes negative only because you take delta G to be minus NFE. Okay, we'll talk about this. Don't worry. In the next 5-7 minutes, we'll talk about this. What affects cell potential? From this, gas electrode मैंने समझा ही नहीं, इसलिए समझ नहीं आया ना प्रीतम. Preetham, what do you want to know about gas electrode? We'll talk about it later on. Preetham, in today's session, let me give you a heads up on what we're going to talk about. ठीक है? कहाँ गया ये? There are multiple things we'll talk about. These are the different types of electrodes we'll talk about. है ना प्रीतम? वहां पे हम लोग आराम से बात करेंगे. यहाँ पे प्रीतम मैं गैस इलेक्ट्रोड बस दिखा रहा था to tell you how to write IUPAC. We'll go over the gas electrode again. ठीक है? फिर से एक बार वहां पूछ लेना. Maybe in the next 5-10 minutes. All right. Cool. So, yeah, funny online. Nernst equation depends on temperature, composition of reaction mixture, partial pressure of gas or any. How did I come up with these 3 points? 1, experiment. 2, I've shown you the math. इस मैथ में देखो ये तीनों चीजें हैं. टेम्परेचर तो डायरेक्टली दिख रहा है. Composition of reaction mixture is in Q. Partial pressure also is in Q. This is how you remember it. If you have to write a theory exam also, how do you remember what points are important? Do this derivation. Do this small little easy derivation. Okay, cool. So, Nernst equation formally is the dependence of concentration and pressure of the gas on the cell potential and can be derived from formula, which I just did for you. I literally did for you. Yeah, here. So, you write down literally for any reaction. कोई भी reaction के लिए this is valid, right? Reaction process anything. Delta G is delta G naught plus RT ln Q. What is Q? Q is reaction progress. Reaction progress. You remember from thermodynamics, if you attended my classes last year में, thermodynamics में हम लोग बात करते थे Q versus delta G की, ठीक है? And irrespective of whether delta G is negative or delta G is positive, you would have an equilibrium position which is delta G equal to 0. This is delta G reaction, this is delta G reaction. यहाँ पे हो गया negative, यहाँ हो गया positive. Either way you would have this. What were you plotting? You were basically plotting G versus Q. इस Q की मैं बात कर रहा हूँ. When Q is equal to K, at that point you reach equilibrium. And at that point, khatam. I'll tell you what I mean. I'll tell you what I mean. Here, back to this right here. From our previous sessions, we know that delta G is minus NFE cell. We know this actually. हम लोग को maybe this may be new, but this is something that is known. अब why did I write E cell? ठीक है, it's the same as this. Delta G naught is minus NFE naught. मैंने temperature constant बदल दिया तो it will be NFE, whatever that E value is. This is unknown. Everything else is known, right? This also can be found. Okay, this is known. How do I get E naught cell? E naught cell तो बस table से है. I know the positive value cathode की, right? Positive मतलब कि E naught reduction cathode minus E naught reduction anode. I know that, so I can get E cell. Okay, great. What is N here? N क्या होता है? वो भी हम बात कर चुके हैं. N is number of electrons taking part in a reaction. Balanced reaction में total number of electrons. वो redox का concept था. That N. Same thing. It's a bit of a recap. श्रेया जी, आप सुन लीजिए. Repeat तो मैं कर ही रहा हूँ. और अगर जो नहीं समझ में आया बता दो, then I will tell you. If you just type repeat, you can literally do that, right? Go back 1 minute and listen again. That is repetition. If you have something you don't understand, point it out. I'm here for you. Okay, cool. So take any reaction, random reaction. Okay. What is Q? This. C bar C, D bar D. This what is from equilibrium. Okay, cool. So now I can write down E cell to be E naught cell minus this. Wait, what did we do here? What did we do? Nothing big deal. क्या हुआ? कुछ नहीं किया यार. Delta G is delta G naught plus RT ln Q. I took, then I wrote this down like this. Okay. Then I just took the other side. Negative sign को मैंने हटा दिया. Plus plus and minus कर दिया. Negative plus I made it minus minus. Plus or minus same thing. I write E is equal to E naught plus becomes minus RT by NF ln Q. ठीक है, यहाँ पे लेगा. अब log को करते हैं from ln, right? So you write as 2.303 log Q into RT by NF. ये यहाँ पे लिखा हुआ है. This is another equation. Mandal ji, thank you so much. I hope this is making sense to you. Thanks for the feedback. If there's anything I can do to make it better for you, please बताइएगा. This is it. This is a Nernst equation. खत्म. That is literally it. Every time you have to figure out क्या करना है, दो चीजें रखिए दिमाग में. Okay. How do you know plus कौन सा होता है, minus कौन सा होता है, E naught किधर, E किधर? Remember this equation. This is the most important thing in this chapter. Remember this. Delta G is delta G naught plus RT ln Q. और इक्विलिब्रियम हो गया तो क्या? इक्विलिब्रियम हो गया तो डेल्टा जी इक्वल टू जीरो. अगर इक्विलिब्रियम डेल्टा जी इक्वल टू जीरो, देन डेल्टा जी नॉट इक्वल टू माइनस RT ln K. Oh, and E naught will be equal to minus RT by NF ln K. बट ये अभी माइनस नहीं होगा, ये प्लस हो जाएगा बिकॉज दो माइनस हो गए. ठीक है, दैट्स इट. That's it. That's the crux of the Nernst equation. Now using this we'll solve questions. चलो यही करते हैं हम लोग, क्वेश्चन सॉल्व करेंगे अब. I can also, if I say temperature is, say, room temperature 273 Kelvin, ले लो इसको. Get a calculator if you want and check this. Okay, let's take temperature to be 273 Kelvin. Then we take R to be 8.314, 2.303 divided by 96,500. क्या मिलता है आपको? 273 नहीं, sorry, 298 ले लो. My bad. Take 298, not 273. Room temperature is 298, not 0 degrees Kelvin. Right. If you take this, खुद भी ट्राई करके देखिए आप. इसको आप टेम्परेचर को लीजिए 298 केल्विन, R is 8.314 SI units में, and F is 96,500. If you do all of this exercise, you will get this value to be 0.059 by N. I will leave N as it is because N is a function of the reaction. उसको मैं थोड़ा ना सब्स्टिट्यूट कर सकता हूँ. ठीक है. So this is a simplified form of the Nernst equation. ठीक है. But be careful, यहाँ पे हम लोग log लिख रहे हैं. 0.059 if you take, you have to write log. Okay. If you don't write that, देखो, we have converted. Okay. We have accounted for 2.303 also inside this itself. इसलिए ये. ठीक है. That's it. That was a quick derivation. Yeah. I hope this makes sense to you. Again, as usual, if you have any doubts, hit me up. Here's the question. JEE एडवांस का सिविल नीट पे करा रहे हो, क्या हो गया है तुमको? कर लोगे तुम. This is my confidence building question for you. You can do this question easily. It's not a big deal at all. To give you confidence that you can solve anything. Really, it's not a big deal at all. So how about we try this question out? Sampath ji and everybody else who's on this chat. Nikhil bhai, Aditya, Mehak, Varad, electrochemical cell. Shreya, if you're here, you can also try this. For the electrochemical cell, magnesium giving magnesium 2 plus and copper 2 plus reacting. E naught value दी है. This is E naught. Then I'm changing the concentration to something else. Oh, then E is this value. What is the value of X? X क्या था यहाँ पे? अच्छा, concentration बदल के X कर दी गई, 1 से X कर दी गई. X की value आपसे पूछ रहा है. And they've been nice enough to give you F by R की value directly. Why do I need F by R? Because देखो, you had what? RT by NF 2.303 ln Q. So they're giving you this constant. ठीक है, टेम्परेचर भी 300 केल्विन दे दिया है. I think we can calculate this. We can do this, right? You want to try this out? Take a minute. If I were to write all of this down on a nice and neat place, here it is, okay? I'm making life easy for you. Initial concentration थी 1 molar. Okay? Then I've changed it to X molar. Right? This is new. At that concentration, E cell is this value. I just have to use this expression to get ki, hey, what is the new concentration of Mg2 plus? Please try it out. Hi Ujjwal, welcome. Try करो भाई. Oh, मेरा पानी दूर चला गया, रुको. Try it out. It looks like very color coordinated with all the purple and shades of, yeah, coincidence, bro. Should we try this out? प्रीतम, look at that, hero. बढ़िया है भाई, तुमने तो जल्दी कर लिया. I like it. I am impressed and I am not easily impressed. प्रीतम क्या किया, थोड़ा अपने दोस्तों को बताओगे? While you tell me, let me help your friends out with this as well. Okay. You take Q to be Mg2 plus by Cu2 plus. Why? This is an important step. Because it is given to you कि यहाँ हो रहा है oxidation, यहाँ हो रहा है reduction. What is the overall reaction? This. Okay. Mg is giving you Mg2 plus. लिखा है यार, एनोड पहले होता है, आयुपैक इसलिए तो पहले आपको पढ़ाया. एंड देन कैथोड में ये हो रहा है. ठीक है. This means what is Q? Q is this. Simple. ये है प्रोडक्ट साइड में Mg2 plus, रिएक्टेंट साइड में कॉपर, इसलिए नीचे आ गया. That's it. This is the first and the most important step. After this तो कुछ effort है ही नहीं, कुछ नहीं करना है. If I put both of them to be 1 molar, then E naught is 2.7 volts. Now, if it is X, if Mg2 plus changes to X, then E is 2.67 volts. So now I'll substitute. Literally just substitute करो. Substitute करने के बाद RT by F आता है. Remember that to put N equal to 2 over here. Why N equal to 2? Because again, see, there are 2 electrons transferred here, same 2 electrons being accepted over here. Okay, sweet. That's it. और T by F तो दिया था 11,500. F by R, sorry. F by R was 11,500. ये 300 डाल दिया, सब कुछ कैंसिल हो जाता है. It's beautiful. So it may seem like, देखो JEE एडवांस का सवाल था और ये सब हल्ला बल्ला, but it's not a big deal at all, right? You get ln x to be 2.303, which means कि e power 2.303 और e power 2.3 is equal to x. अब ये तो आपको दिया हुआ है कि ln 10 is equal to 2.3. So that's the answer. 10 is the answer. Yes, बिल्कुल सही प्रीतम. Excellent work. Excellent work. निखिल भाई, तुमने भी सही किया. क्यों ट्रैक कर रहे हो मैसेज यार? अजीब आदमी है. आंसर सही देके भी मैसेज ट्रैक करता है. कौन करता है ऐसा जोशी भाई? इतना डैपर लग रहे हो तुम अपने येलो, सॉरी, ग्रीन सूट में. ऑल राइट, गुड जॉब भरत. ऑल राइट, नाउ व्हाट इज द कॉन्सेप्ट ऑफ इक्विलिब्रियम? इधर इक्विलिब्रियम हम लोग नॉर्मल रिएक्शन में तो समझते ही हैं, राइट? वी अंडरस्टैंड व्हाट इक्विलिब्रियम मींस इन अ रेगुलर रिएक्शन, बट व्हाट इज इक्विलिब्रियम इन एन इलेक्ट्रोकेमिकल सेल? एंड इसके मैं हिंट्स आपको पहले सेशन से दे रहा हूं. डेथ ऑफ अ सेल, बहुत डर रहा हूं आपको कि अगर इक्विलिब्रियम होगा तो चीजें खत्म. बिकॉज इट इज ट्रू, if things reach equilibrium, that means there is no potential difference. Okay, and that's a problem. Okay, so thermodynamics say, if you go about this same equation जो पहले से थी, when delta G is equal to 0, then E cell is equal to 0. I That's it, right? That's it. All I was saying from the starting. यही तो मैं शुरू से बोल रहा था. देखो यार, mathematically also you see, delta G is minus NFE. Equilibrium क्या था? Delta G equal to 0. That means E cell is 0, right? At equilibrium. That's what I was saying. Death of cell. मतलब cell does not work anymore. That's it. So, and by the way, this is important. This is not at 1 molar. Okay? ठीक है? सोचो थोड़ा. 1 molar पे Q थोड़ी ना 1 होगा. I mean, Q will not be equal to K, no? Q will be 1 at if everything is 1 molar. That is not what we are talking about. If Q is 1, then you get E naught. Are you able to catch on to this? Is this making sense to you or not? Maybe yes, no, maybe. Why am I saying Q is 1? You take all concentrations to be 1 molar, all pressures to be 1 atmosphere, and obviously Q will be equal to 1, no? Cool. Yes, no, maybe. सोचो थोड़ा इसके बारे में. ठीक है? And mathematically, if you take Q to be 1, this becomes 0. That means that delta G equal to delta G naught, which means E equal to E naught. Mathematically भी prove हो गया यार, है ना? E cell is equal to E naught when Q is equal to 1. So everything ties in beautifully with the math. अगर ये ज्यादा हो गया तो खुद एक बार ट्राई करके देख लेना. ठीक है? Cool. let's get back to the point of equilibrium, why I was saying it was death of cell. But see, it may seem like it's a bad thing, but at equilibrium, what I also get is this E naught cell value theoretically. Theoretically, we can calculate this. Okay. Is it? Any doubts, guys? Yeah. Again, substitute everything, right? This is 0.059. What am I writing as 0.059? 2.303 into R by F into T, where T is 298 Kelvin. This value is equal to 0.059. Since वो denominator में नीचे चला जाता है, log 1 KQ is equal to this. Please don't mug this. Do not mug. If needed, derive it on the spot and do it. You have to get used to that. I know the students who are on NEET are a little bit scared of all of these things, but नहीं, ऐसा नहीं होता है, कुछ नहीं होता है. It's a बहुत very doable things. You just have to need a little bit of practice. And this is not maths, this is just derivation. That derivation भी क्या है? You're literally playing with alphabets. Where's the math? There is no arithmetic. Okay, division करना है यार बस, ठीक है. From the equilibrium constant at 298 Kelvin, it's not just NEET, even JEE students don't like this. They're like, oh my god, electrochemistry is hard. No, bro, it's not hard. It's hard. It seems hard because you got to do the whole of thermo से पहले. पूरा gaseous state करना है, पूरा equilibrium करना है. इसलिए मुश्किल लगता है. If you've done all of that, this is lovely. It's fun. Okay. Find the equilibrium constant at 298 Kelvin for the reaction Cu2 plus In. Yeah, this is not L, okay. Indium hai. Indium 2 plus gives you indium 3 plus Cu plus. Given that, this is interesting now. Okay, this is the cathode reaction, but the anode reaction is kind of funny. Anode में दो दिया हुआ value. How do you do this question? This is the most hardest question that's ever going to come in JEE or NEET. JEE Advanced, obviously, you're going to be using this and something else usually. This is a PYQ, okay, from JEE. But for JEE and NEET, if you understand this, you've pretty much done the whole of Nernst equation. This is it. Yeah, this one equation, this one question covers all the concepts we've done so far. Okay. So can you try this one out? Please, Kariya. Yeah. Do you know how to do this anode wali cheese? Does it look complicated at all? इधर हो क्या रहा है? What is anode में लिखा? Sir, write down. You guys try it out. If anyone knows what to do, please do it. Let me try and dissect ये लिखा क्या है. Let's हमको what do we know? We know that I can write this like this: Cu2 plus to Cu plus, right? Plus one electron. इसका is 0.15 volt. Similarly, I can write down indium 2 plus to indium plus electron. This value is given to be something. कुछ है minus 0.4 volt. जो भी है, value is not important. Okay. दूसरा में क्या दिया है? यहाँ पे दिया है कि indium 3 plus gives me indium plus and 2 electrons को add करो, इसको दिया है minus 0.42. This is given. What do I need? I need indium 2 plus giving indium 3 plus. मतलब देखो क्या करना है, मतलब you may be tempted कि equation 1 and equation 2, if I do equation 2 minus equation 1, I am sorted. Looks like that, है ना? Looks like that. ठीक है, ये करते हैं, but what are you subtracting? Are you subtracting E naught values? Are you subtracting delta G values? Can you do both? क्या करोगे? If you have an idea, let me know in chat. क्या करोगे? कोशिश करो. What will you do? Will you do E naught, delta G या दोनों? क्या subtract करोगे? बताओ. Do you know how to do this? ये लॉजिक तो बिल्कुल सही है, राइट? आई हैव गॉट दीज टू एंड आई हैव गॉट टू गेट टू दिस, तो मे बी मैं इन दोनों को सब्ट्रैक्ट कर सकता हूं, बट किस वैल्यू को सब्ट्रैक्ट करेंगे, ई नॉट या डेल्टा जी? यू कांट डू ई नॉट, क्योंकि ये है इंट्रिंसिक प्रॉपर्टी, ओके, एंड these are extensive properties. Delta G is an extensive property. ठीक है, इंट्रिंसिक इंट्रिंसिक बता चुका हूं यार बहुत बार, अगर ये नहीं समझ आ रहा है, यू हैव टू रियली रीड थर्मो, ओके, यू नीड थर्मो टू डू इलेक्ट्रोकेमिस्ट्री. एक्सटेंसिव मतलब कि डिपेंड्स ऑन मास, डिपेंड्स ऑन नंबर ऑफ पार्टिकल्स. ई नॉट डज नॉट डिपेंड ऑन ईदर ऑफ दोस थिंग्स. व्हाई डज दैट मैटर? बिकॉज what I have at the end is also a redox reaction. Let's just say a reduction oxidation half. ठीक है, it is not the full reaction. अगर full reaction होता then I could do E naught plus or minus. प्रीतम, thank you for that answer. 10 by 11, lovely. Thank you for that quick answer. नीट एस्पिरेंट जी, क्या समझ नहीं आ रहा है बोलिए. आपके हुक्म पे हम लोग हिंदी में तो बात कर लेंगे, बट आपको समझ में भी आना चाहिए. मैं आपको जो भाषा चाहिए आपको मैं कन्नड़ा में भी समझा दूंगा, बट आपको समझ में आना चाहिए. व्हाट इज इट दैट यू डोंट अंडरस्टैंड? यू टेल मी दैट एंड आई विल गेट टू दैट. लैंग्वेज इज नॉट अ बैरियर हियर, ठीक है, समझना ये जरूरी है. तो बताओ क्या नहीं समझ आ रहा है, ठीक है. इज दिस ओके? आई एम गेसिंग प्रीतम को समझ में आ गया, बिकॉज अगर वो आंसर उसको मिल गया तो प्रीतम हैज डन दिस. वरद, हैव यू ट्राइड दिस आउट? ये क्वेश्चन आप कर पा रहे हो? You cannot subtract E naught. You must work with delta G. This is the important bit. Is this okay? Give me a thumbs up if this idea is okay. We'll do it. We'll do it together. कैसे करेंगे delta G को? I'll help you with that. But you can't do E naught. Okay? That's important. लगता है नीट एस्पिरेंट जी भाग गए. भाषा भाषा लेके बात करते हैं, सवाल नहीं करना है, सॉल्व करो भाई, टाइम पास तो ठीक है. All right. So E is E naught minus RTL and Q. That's my standard equation. E naught cathode is given to me. वो आपको बोला था शुरुआत में. Now, what do I do for the anode? For the anode, I'm going to do जो मैंने आपको बोला था. I am playing around with delta G. How? Because E naught, I can't add directly, but I can add NF E naught. This can be added. क्यों? क्योंकि ये है delta G naught. Specifically अगर देखा जाए तो delta G naught equal to negative NF E naught. ठीक है? So delta G naught of which reaction? Now delta G naught किस reaction की बात कर रहा हूं मैं? यहां वापस जाते हैं इधर. Reaction 3, right? This is the third reaction. Oops. Delta G naught of this reaction, इसमें बस एक इलेक्ट्रॉन है, ठीक है, will be equal to 2 minus 1. 2 में 2 इलेक्ट्रॉन थे, so 2 into F into E naught of 2 minus 2 हम लोग रोमन में लिख रहे हैं तो फिर से रोमन लिख देते हैं, माइनस एक इलेक्ट्रॉन था पहले वाले में into F into E naught of 1. This will be delta G naught of 3, which is exactly हमने यहां पे जो लिखा है, ठीक है. एंड सिंस दिस हैज जस्ट वन, तो दिस गेट्स दिस. सॉल्व कर रहे हैं, बहुत अच्छी बात है. देखते हैं प्रीतम, आई होप सो टू. गुड जॉब, जल्दी जल्दी आपने किया. लेट्स होप दैट योर्स इज करेक्ट. देखते हैं, अगर कुछ आगे पीछे लगे प्रीतम तो बताना, ठीक है. नाउ यू हैव गॉट डेल्टा जी नॉट ऑफ एनोड, ठीक है. ई नॉट से अब क्या हुआ? कुछ नहीं हुआ, 0.59 वोल्ट्स हो गया. दैट्स इट. ब्यूटीफुल, इजंट इट? यू गॉट 0.15 माइनस ऑफ 0 माइनस ऑफ negative 0.44, दैट बिकम्स 0.59. ओके, स्वीट. अब आगे क्या बाकी है? हमको निकालना है, ओ हमको निकालना है के. के कैसे निकालेंगे? एट इक्विलिब्रियम यू विल से E is equal to 0. E naught into NF by RT is ln K. तो log K हो जाएगा इतना. दोस्त, मुझे लग रहा है कि log K तो 10 आ रहा है मेरा, मतलब कि K will be 10 power 10. प्रीतम जी, आप 11 बोल रहे थे, आपको 11 कैसे आया? कैन यू हेल्प मी विद दैट प्लीज? हाय राघव. प्रीतम, do you see how the answer is 10 power 10? Can you help me see how you got 11? 11 would mean you had this plus 1 somehow, right? मैं वो समझ नहीं पा रहा हूं कि वो कैसे हुआ. अगर इसमें कुछ डाउट है प्रीतम, and you want to share what your working was, you can ping me, you know where, right? I teach chem, you can find me on Telegram or on Discord and we can chat there. But I feel that the answer should be 10 power 10. Okay? As I told you, हम लोग एक सवाल करेंगे, बट इतना ठीक से करेंगे कि पूरा चैप्टर वहां खत्म हो जाए. दिस इज दैट वन क्वेश्चन फॉर नर्न्स्ट इक्वेशन. व्हाट डिड वी कवर? वी कवर्ड कि भाई डेल्टा जी नॉट अगर तुम्हारा E naught values अलग अलग दी गई हैं, you're still getting a redox reaction like indium वाला. You've got two of them, right? Though half reactions combined into a third half reaction. How to deal with that? We did that. We dissected the pura equation. We figured out how to get K. And हमने Nernst equation properly लिखी भी. That was the first step. ठीक है प्रीतम, सही है? Okay, cool. Let's move on. आगे बढ़ा जाए. नीट एस्पिरेंट जी, ये तो मैंने पूरा हिंदी में ही बताया. आपको समझ में आया? कुछ नहीं समझ में आया? कुछ अगर if there's anything you did not understand, मुझे बताइए. I'm here to help you. But I feel कि it should be doable, but it's all right. अगर नहीं समझ में आ रहा तो कोई टेंशन नहीं है यार, कोई बड़ी बात नहीं है. We'll figure it out. That's the wonderful thing of being online ना. You can take your time, आराम से जो चाहो कर सकते हो. All right. एक second. Let me give you guys the link of how to reach me on Telegram, Discord, etc. There you go. Yeah. The first link takes you to all my sessions in general. If you want to join Telegram and Discord discussion groups, you can do that. The second link takes you to the app, the Aakash BYJU'S app. There's some crazy animations of this actually, and soon I'll show them, share them with you. Electrochem is a very, very well done chapter. It's fun. बहुत डिटेल में किया हुआ है यार. ओके, सो अलग अलग टाइप की जो सेल होती है उसमें कैसे निकालें नर्स्ट इक्वेशन. अभी कोई बोल रहा था ना उसको गैस इलेक्ट्रोड समझ नहीं आ रहा था, तो मैंने समझा नहीं था. अच्छा प्रीतम था क्या? नो, तो समबडी एल्स आई थिंक. गैस इलेक्ट्रोड समझ में नहीं आया. कौन बोल रहा था यार? निखिल था शायद. निखिल जो सब मैसेज रिट्रैक्ट किया है. अच्छा प्रीतम भी बोला था. ठीक है, डोंट वरी, वी गॉट यू कवर्ड. गैस इलेक्ट्रोड क्या होता है, वी डू दैट. ओके, सो दिस फर्स्ट वन इज द मोस्ट कॉमन. हम लोग इसको बहुत बार देख चुके हैं. ठीक है, दीज आर डिफरेंट टाइप्स ऑफ हाफ सेल्स. ओके, metal soluble salt electrode. Sounds scary but it's not. Metal मतलब zinc. Metal soluble मतलब zinc 2 plus, और copper 2 plus is what this is. Gas electrode मतलब SHE. Redox electrode may be new to you but it's okay. Metal insoluble salt electrode, ये दोनों सेम में आते हैं actually. Calomel is a type of metal insoluble salt electrode का टाइप का ये. We'll see. We'll look at all of these. All right, ठीक है, एक एक करके देखते हैं. पहला वाला is direct, right? This is something we have done all this time, but we can quickly look at it as well. 1 second. I've lost your chat. Where is the chat? Here is the chat. एक second. All right, here we are. Cool. So this is just like zinc, Zn2 plus, copper 2 plus, copper. वही चीज है. Yeah, I'm writing in terms of a generic reaction, and remember that this is the phase boundary. Yeah, this is the reduction half. इसलिए ऐसे लिखा है. पहले हम लोग लिख रहे हैं ion, then the reduced form. ठीक है. नर्न्स्ट इक्वेशन इसमें कैसे लिखोगे आप? हाय सर जी, वियर्ड नेम बट ऑलराइट, प्रणाम. पॉजिटिव प्रो, व्हाट इज दैट? खैर, इफ आई वर टू राइट इट लाइक दिस, यहां पे रिडक्शन हो रहा है Mn plus. This is not manganese, okay? It's just some metal M, which is giving you solid, which means Q is going to be M solid divided by Mn plus. And you know from equilibrium that this is considered to be constant, तो हम लोग इसको equilibrium constant या Q में ही डाल देते हैं. So we take this to be 1. ठीक है? That's why this is there. Revision of what we've done before, nothing complicated there. So E is equal to E naught minus this. ये चला गया denominator. Why? Because we took the reduction half cell. If you took the oxidation half cell, this would be the numerator. That's it. ठीक है. ऑक्सीडेशन हाफ सेल में उल्टा हो गया, ये ऊपर आ गया, राइट? इंस्टेड ऑफ 1 बाय मेटल M plus, it became डायरेक्टली ऊपर आ गया. ठीक है, कूल. नो डाउट्स हियर, वी आर गुड. डाउट है तो पूछ लो, ऐसा नहीं कि नो डाउट्स हियर, कोई डाउट नहीं, आगे बढ़ो. बट दिस इज जस्ट अ वे ऑफ राइटिंग जो हम लोग पहले ऑलरेडी कर चुके हैं. अब इन दोनों को कंबाइन करो तो आपको पूरा सेल मिल जाएगा, राइट? दिस वाज द इमेज दैट आई वाज टॉकिंग अबाउट, जो हमने फर्स्ट 2 सेशन में भी देख चुके हैं, जिंक और Nernst में. यू कैन हैव मेनी डिफरेंट एग्जांपल्स ओवर हियर. ऑलराइट, gas electrode, which was also something we've covered, but we look at, हम लोग IUPAC का जो nomenclature देख चुके हैं उसको यहाँ पे अप्लाई करेंगे एक्चुअली. ठीक है. Now at 298 Kelvin, there are 3 things written over here. You take a platinum foil. That is where the reaction happens. This is called an inert electrode. मतलब वो खुद ही, it does not take part in the reaction, but it facilitates the reaction. Facilitate कैसे? It's a conductor, पहली बात. और वो reactive नहीं है, मतलब पर उसका सरफेस ऐसा है कि उसके सरफेस के ऊपर रिएक्शन हो सकते हैं. क्यों? You learn in D block why platinum is so good for this. Okay, react नहीं करता, and also it's great for catalysis and all of that. ठीक है. So we take platinum, it's very expensive, you know that, right? Gold के बाद diamond, बीच में platinum somewhere. It is finely, it is coated with finely powdered platinum black. Why? You learn in DNS block. Yeah, catalysis के लिए actually हम लोग kind of उसको cover कर चुके हैं. When we did kinetics, we have kind of covered it, but in D block it will be better. But I'll be honest with you, catalysis कैसे काम करता है किसी को मालूम नहीं है. Like literally nobody knows. But we just know it works and we're like, hey, great, Mother Nature, let's use it. I'm being very honest with you. ठीक है. इसको dip करते हो आप लोग acidic solution of 1 molar HCl. Why 1 molar? Because standard state, right? You want to do E naught value. Okay. And pure hydrogen gas, which is really hard to get and store because hydrogen इतना छोटा होता है. You bubble it at 1 bar into the solution. 1 bar, again, 1 atmosphere, 1 bar, more or less same, but now NCERT changed it to 1 bar, so we'll also say 1 bar, 1 molar HCl. This is the setup. Okay, okay, cool. So, pure H2 gets adsorbed. What is adsorption? पढ़ा है यार, maybe नहीं पढ़ा है because syllabus हटा दिया, but I have done session on this. I have done session on this. Go to the bento link. Look at adsorption क्या होता है अगर आपको डिटेल में पढ़ना है. Read NCERT यार, it's not rocket science. Please read adsorption. Adsorption मतलब surface phenomena है, ठीक है? अंदर नहीं आता है, surface पे होता है, ठीक है? Now because H2 gets adsorbed, now उसको पकड़ लिया है. Platinum has got hold of it. So it has nowhere to go. It has to now react with H plus. Right? At least there's a tendency of them to react. मतलब H2 to become H plus और H plus to become H2, ये दोनों चीज की टेंडेंसी है. अब ये कैसे, which direction will the reaction happen in? That depends on what you connect to it. देखो, reduction or oxidation halves are just halves. उसके साथ when you connect something else to it, that's when a reaction actually happens. Okay, but we're trying to understand SHE, how it functions and all that. So what is the phase boundary now? इसीलिए हम लोग बोलते हैं कि प्लैटिनम के साथ होता है H2 or this way. You can write it in both of these ways. Now which way will you write it depends on what is happening. ठीक है? What is happening मतलब ये तो एक फेज हो गया, एक और फेज है. दूसरा फेज कौन सा है? H plus. This is say some concentration. I'm just writing C. You can write it as 1 molar, जो भी आप लिख सकते हो. Or this. ठीक है? These are 3 phases. So this is oxidation. This is reduction. So अगर आप कैथोड पे लिख रहे हैं, then you will write like this. अगर आप एनोड पे लिख रहे हैं, then you will write like this. ठीक है? Mandal ji, did you understand this? Is this clear? Of course, when I'm writing this, the best way to do this would be to specify what is the pressure. So I would say 1 bar, and I will say H plus, which is aqueous obviously, but also I will say 1, molar. Similarly, यहाँ पे concentration वो सब चीज लिख लेंगे, ठीक है? So reduction oxygen दोनों है platinum foil पे. So if this is acting like an anode, if SHE is acting like an anode, this is the cell representation. Mandal ji, gas electrode is clear? The reason there are 2 bars is because there are 2 interfaces. दो interface क्या है? Interface मैं आप loosely use कर रहा हूँ, but I think you understand what I mean. Interface is not a complicated word. Interface मतलब जहाँ पे reaction हो रहा है. The phase, दो phase boundary है. पहली phase boundary solid और gas के बीच में, ठीक है? Next phase boundary is between this gas and the H plus ions. ठीक है? Cool. So you'll either write it in this direction or in the opposite direction depending on whether there is oxidation or reduction happening. देखो opposite direction मतलब ऐसे लिख रहे हो to show that there is reduction happening. This is it. This is the gas electrode. प्रीतम जी, कोई डाउट है तो बता दीजिए. This is what it looks like, etc. etc. ठीक है? इसमें आप KCl भी यूज कर सकते हो besides this thing. And Cl2. This is interesting, right? This is an example of another of basically Cl minus 2Cl2, this gas electrode. ठीक है? इसलिए you also have F2 being formed from F minus. All of them are gas electrodes. All right, ठीक है. तो क्लोरीन का कैसे लिखोगे? Same चीज. If it acts as a cathode, this is reduction that is happening. You will see that the ions have changed. हाँ ना, main चीज है reduction and oxidation. It doesn't matter. H plus and Cl minus are not that important. कि कहाँ लिखोगे? The important thing is this. कि if it's cathode, the reaction must represent reduction. The IUPAC nomenclature should show कि reduction हो रहा है. अगर cathode पे, अगर oxidation हो रहा है तो anode पे दिखना चाहिए ऐसे. Is this all right? Yeah. This is different from the H plus. Obviously अलग ही होगा ना, क्योंकि anode में ये हो रहा था. This is the difference. I am writing the difference here so that you're comparing apples to apples. ठीक है? This was anode for H plus. फिर से दिखा रहा हूं, एनोड में उल्टा था. ठीक है? तो प्लीज मग मत करिए. पीटी के अलावा दूसरा और कोई मेटल ले सकते हैं. प्रीतम, if there's any other inert electrode you can take it, but I think at our level I have primarily seen PT. Platinum is an inert electrode. ठीक है? प्लैटिनम के अलावा और कोई nothing comes to mind right now, but I'll look it up and get back to you in the next class. ठीक है? अगर कोई और भी होता है. It's a nice question. Thanks प्रीतम. Thanks for asking this. ठीक है? मेन चीज है मग मत करो. Try and do this from first principles. If you try and mug it, this becomes very complicated. कि यार लेफ्ट में राइट में कहाँ हुआ क्या होगा. लॉजिक क्या है फिर से मैं बोल रहा हूँ. There are going to be two phases, two phase boundaries. तीन फेज होंगे. एक तो सॉलिड, दूसरा गैस, तीसरा आयन. ठीक है? तीन फेज होंगे. मतलब दो फेज बाउंड्री होगी. Now phase boundary कहाँ कौन सा की चीज कहाँ लिखोगे depends on whether it's oxidation or reduction happening and what is the species. अगर H2 से H plus बन रहा है, that is different because you're getting a cation there. Here you're getting an anion. You're taking a gas like chlorine or fluorine, उससे anion बन रहा है. ठीक है? तो अलग है. तो ध्यान से देखो, analyze it and figure it out. And if you want to revise, ये notes तो हैं आपके पास. Take these notes and revise. ठीक है? Awesome. Let's take this question. A hydrogen gas electrode is made by dipping platinum wire in a solution of NaOH of pH 10 and by passing hydrogen gas around the platinum wire at 1 atmosphere pressure. The oxidation potential of electrode is 10x millivolts. Find X. All right. Parth ji, derivations of PC come in board CBSE. हाँ आते हैं. Derivations तो आते ही हैं. Boards में तो जरूर आते हैं. आप 3 बार बोलोगे तो 3 बार आ जाएंगे पार्थ जी. Shall we try to solve this question? Or if you feel this is difficult, how about you take this as homework and we'll do this in the next session. Let's cover all of these other electrodes. एक shot में कर लेते हैं. Okay. Take this as a homework. Let me tell you what I will do. Let me cover the other electrodes quickly first. Okay. This is easier to do. I feel like if I do that question, आप लोग थोड़ा switch off कर जाओगे. Let's do this. Redox electrode क्या होता है? Let's do that. Yeah. Redox electrode is basically reduction or oxidation. तो सब जगह हो रहा है. What's the big deal? Okay. The difference here is that you've got the same substance in different oxidation states. Example लेते हैं, समझ में आएगा, है ना? Here, platinum wire is used as electron carrier. मतलब inert electrode, भाई सेम चीज बोल रहे हैं. मतलब क्या हुआ? देखो, I've got a platinum wire over here और solution में मेरे पास Fe2 plus Fe3 plus दोनों है. ठीक है? This is going to be most relevant to D block elements because they show multiple valencies, multiple oxidation states. ठीक है? So again, reaction कहां पे हो रहा है? Platinum electrode पे. ठीक है? Okay. And यहाँ पे क्या हो रहा है? This is an anode as it says. Only one phase boundary. And remember मैंने Sn2 plus, Sn4 plus दिखाया था. That was also the same thing. Exact same चीज. That was a redox electrode. ठीक है? यहाँ पे जो है स्टेन यानी कि स्टैनम can exist in +2 and +4 states. Here we are talking about ion that can exist in both states and ये एनोड वाला हाफ दिखा रहे हैं. इसी सेम चीज को मैं कैथोड हाफ दिखा सकता हूँ. How can I do both? Because this is only a half ना. इसके बगल में क्या है? What is the next half? That is what decides who's going to behave like an anode or cathode. बार-बार मैं इसको ये बोल रहा हूँ. ठीक है? All right. Varad, this is good. Preetam, Sarji, all good. Raghav, this is the redox electrode. Okay, so here is an example of a redox electrode. MnO4 minus. This is from redox. आप लोग इसको बैलेंस बहुत बार कर चुके हैं. In an acidic medium gives you Mn2 plus. Okay, और इसमें कितने इलेक्ट्रॉन ट्रांसफर होते हैं? 5, right? Because oxidation state of 7 plus to 2 plus. So the change of 5 electrons. इसलिए n is equal to 5 right here. ठीक है? And why am I writing like this? Because this right here is Q. Oh, this is scary. H plus power 8. I'll take H plus to be 1 ना. 1 molar है, कोई फर्क नहीं पड़ेगा. This goes away. ठीक है? This is what you have to worry about. Usually 1 molar पे होता है. Now in JEE advanced or maybe in some really complicated question of JEE or even in NEET, maybe they'll say H is not 1, it's 0.5. Then you have to sit into 0.5 power 8 or something like that. But नहीं होगा. This is not going to come for you, trust me. But you should know how to derive it. करना आना चाहिए. ठीक है? Remember, here again, platinum is used as the current carrying conductor. मतलब electrons platinum wire के through जाएंगे बाहर the outer circuit. ठीक है? Another example is, as I told you, Sn2 plus, Sn4 plus. The last one for today, we have 5 more minutes, let's see how much we can get done. Is metal insoluble salt electrode. इसका मैंने एग्जांपल आपको लास्ट सेशन में दिया था. I don't know if you remember it, maybe जो है जल्दी में याद था नहीं था, let's see. But I'm gonna go ahead and show that to you again कि it is in NCERT. I'm not doing something crazy for you. ठीक है, आपको डराने के लिए नहीं कर रहा हूँ. मैं जो भी आपके साथ कर रहा हूँ NCERT ही कर रहा हूँ सिर्फ. ठीक है, बिकॉज जेईई मेन और नीट के लिए मोर देन एनफ. ये एडवांस में थोड़ा और एफर्ट लगता है, बट जेईई मेन और नीट के लिए ये. दिस इज अ मेटल, एग्जैक्टली ये मेटल insoluble salt electrode. What do I mean? It says यहां पे मेरे सर के ऊपर, थोड़ा जूम करते हैं, AgCl प्लस इलेक्ट्रॉन. AgCl देखो सॉलिड स्टेट में है, ठीक है, AgClS लिखा है, एंड यहां पे भी AgS आ रहा है, which is interesting, right? But look at the change in oxidation state. Oxidation state Ag plus का Ag0 हो रहा है. Chloride is -1, chloride is still -1. So essentially what is happening is equivalent to saying Ag plus becoming Ag. But it is different. It looks like it's that, but it's different. If you look at the value of just Ag plus, देखो, only Ag plus in Ag is 0.8, okay, which I told you was the actual midpoint. दोनों reducing oxidizing हो सकता है, if you remember that extra information. But if I take something else like AgCl, AgBr, उसके अलग अलग values है, ठीक है, so it's very very interesting. So इसकी value बदल क्यों रही है? Why is it that this value is changing? Because of this in the mix. So the KSP of these values is going to influence कि कितना Ag plus निकल पाएगा solution में. KSP मतलब बहुत ही थोड़ा small quantity of Ag plus will be able to come out into the solution. ठीक है, we will explore this briefly. And अगर इसमें doubt है, you know where to reach me. But I think this is very very interesting idea. And since NCERT में इसको mention कर दिया, I think we should cover it. Okay, we won't go in too much detail, but we should cover the basic ideas and how ये आया कहाँ से. ठीक है, तो metal rod है, coated with metal insoluble salt. मतलब कि metal rod के ऊपर मैंने AgCl डाल दिया. Okay, metal rod. So I've got Ag and AgCl, दोनों solid है. बट इन दोनों के बीच में भी इंटरफेस होगा, राइट? देयर इज अ फेज बाउंड्री बिटवीन देम. इज देयर? विल सी, देखेंगे, ठीक है. और उसको हम लोग डालेंगे एक सैचुरेटेड सॉल्यूशन में ऑफ KCl. व्हाई? बिकॉज़ दैट Cl- आयन, दिस इज द कॉमन आयन बिटवीन देम. ठीक है, not in Ag plus. Okay, that makes no sense. Don't do that. Why are we putting Cl minus? Because Cl minus यहाँ भी था, यहाँ भी है. Okay, what is changing is plus. यहाँ पे 0 है oxidation state, यहाँ +1 है. So this is the reduction we're talking about, Ag plus to Ag. I'm going to read that one more time. Consider a metal rod coated with metal insoluble salt and dipped into an aqueous solution containing an ion of the insoluble salt. Anion Q, I told you the main reduction is happening from Ag plus to Ag. Okay, now see this. Okay, AgS plus Cl minus gives you AgCl plus E. This is the whole reaction. And notice that again there are 3 phases. तीन कौन से फेज है? एक तो तुम्हारा सिल्वर रॉड, नॉट प्लैटिनम एनीमोर. you've got a silver rod. This is similar to that. या प्लैटिनम अगर था वहां पे, पिछले जन्म में बोल रहा था, पिछले स्लाइड में PTS था, राइट? एंड देन यू हैड से सम अदर थिंग, राइट, गोइंग ऑन. यहाँ पे हम लोग देख रहे हैं कि देखो, दिस इज पहला तुम्हारा सब्सटेंस सिल्वर, देन यू गॉट AgCl जो उस पे कोट कर रहे हो, देन देयर इज अ फेज बाउंड्री, देन अनदर फेज बाउंड्री एंड द सैचुरेटेड सॉल्यूशन. सो दिस इज द सेल रिप्रेजेंटेशन. ये क्या हो रहा है? ये एनोड है. व्हाई इज दिस एनोड? बिकॉज यू आर गोइंग फ्रॉम 0 to +1. वरद, ऑल गुड? प्रीतम, भारी हो गया? चल रहा है, समझ में आ रहा है या फिर भारी हो गया? This is the most heavy thing in this chapter. अगर ये समझ गया, you're done. This is like the most complicated thing theory wise, but it becomes easy if you do this one step at a time. Now we'll break this up. इसको हम लोग तोड़ेंगे into 2 parts. How do we break this into 2 parts? देख बताता हूँ. ठीक है. Now अगर मैं इसको कैथोड में देखूं तो रिएक्शन रिवर्स हो जाता है. ठीक है, यहाँ पे भी सेम चीज हो रही है. इंस्टेड ऑफ गोइंग इन दिस डायरेक्शन, इस डायरेक्शन में इसको उल्टा कर देंगे तो कैथोड हो जाएगा. उल्टा डायरेक्शन मतलब पहले Cl minus, then AgCl, then Ag. Remember, I've got the silver rod, उसके ऊपर AgCl कोट किया है, and then I've dipped that in a solution of KCl. That is what we're talking about. ठीक है? Okay. Now, how do I simplify this? ये हम लोग कर रहे थे समझने के लिए सेल कैसे कंस्ट्रक्ट होता है. अब E नॉट कैसे निकाले सेल का? E नॉट में दिखाया ना 0.22 या कुछ था. How did you get to that? How did we get to that? वो नंबर अलग अलग क्यों था? फिर से दिखा दूं. E नॉट अलग किस चीज का? देखो ये E नॉट for AgCl and AgBr. Why is it different? I told you, I gave you hint because it's because of the KSP values. कितना डिसॉल्व होता है? डिसॉल्व होता है, हाँ डिसॉल्व होता है. इंटरेस्टिंग. बहुत कम डिसॉल्व होता है, बट थोड़ा तो होता है ना. दैट्स व्हाट KSP मींस. इनसॉल्युबल सॉल्ट है, बट बहुत थोड़ा सा Ag प्लस हो जाता है. दैट बहुत थोड़ा सा ही इज द रिजल्ट, इज द कॉज ऑफ द E नॉट वैल्यू. ओके, रिडक्शन पोटेंशियल इसका हम लोग कैसे निकालें ई नॉट का, ठीक है। रिडक्शन पोटेंशियल निकालने के लिए लेट अस टेक द कैथोड हाफ, ठीक है, उस डायरेक्शन में मैं ले रहा हूं। ओके, आई टोल्ड यू दिस कैन बी थॉट ऑफ एज समिंग दीज टू इक्वेशंस। कौन से दो इक्वेशन? एक तो केएसपी वाला, दूसरा ये हमारा ऑसम सा standard reduction potential of Ag plus giving Ag. This I know is 0.8 volt. This also I know KSP value from data, I know this, and using both of these, अगर मैं इसको add करूं तो क्या हो जाएगा? If I add both of these, you see Ag plus gets cancelled, and what I get is AgCl giving me Cl minus plus Ag. And note, यहाँ पे एक और electron, right? So this is a half cell. Okay, great. Since यहाँ पे both of these are single electron systems, I can pretty much add them, but actually effect क्या है? मैं delta G को add कर रहा हूँ, ठीक है? It looks like we are just adding up E naught values, but we are actually adding up the delta G naught values, ठीक है? देखो, delta G naught इसका है 2.303 log KSP, इसका delta G naught is NF E naught. N happens to be 1 over here. Now, after you do all of these awesome things, you get total delta G is this, sub करिए, and lastly, you get this awesome equation. This is 0.8, this is known. साथ में हम लोग इसको लगाएं तो what you get is E naught, which is 0.8 volts plus 2.03 RT NF log KSP. Oh, isn't that wonderful? ठीक है, E naught हमने निकाल लिया, E naught of this reduction potential of metal insoluble salt electrode, जिसमें Ag rod, the metal rod itself, is the current carrying conductor. उस पे coated है AgCl and it is a saturated solution of KCl. All right, cool. कोई doubts है क्या? भरत, पार्थ, प्रीतम, any doubts so far? Are you good? Anybody else who's silent but कोई बोल नहीं रहा है? It's okay. Pipe in, ask me doubts. जो पूछना है पूछ लो. At this point, I'm open to taking questions because I know that sometimes this can be hard. But hey, this is very doable. Okay? Just follow the maths and it will be doable. ठीक है. ये हमने E naught निकाल लिया. अब E कैसे निकालें? E cell कैसे निकालें? E cell is E naught minus RT ln Q, है ना? अब RT ln Q कैसे करें? देखो, ओवरऑल इक्वेशन में सिर्फ एक ही तो आयन है. Just one ion is literally just got one ion overall में, ठीक है? तो E naught, E will be E naught, जो हमने पूरा यहाँ पीछे किया था ना, this was E naught, this big thing, this whole thing is E naught, okay? ये पूरी चीज, ठीक है? And this right here is ln Q or 2.303, ठीक है? Log Q is just Cl minus because on the RHS I've got chloride ions. That's it. That's it. और उन दोनों को अगर आप साथ में करो, substitute this, then all of this comes together and you get this expression which you can use directly. Yeah, if you see this somewhere, आप इसको directly use कर सकते हैं. You can directly use this in questions, but you don't have to. You can also derive it on the spot. It doesn't take that much time. What you've got to do is do 10 questions from this topic. That's it. You're sorted. ठीक है? Here, the situation, since it is saturated with AgCl, you can write this whole thing to simply be equal to 1 by Ag plus, right? ये saturated है, ठीक है? Cl minus की value आपको मालूम है. So lastly, I can literally write this whole thing to simply depend on Ag plus, which is what it actually is. Okay? And in the end, you get E to be the same as this. Okay? हाँ, I feel like आज काफी भारी हो गया, तो let us keep calomel electrode for next time. ठीक है? Calomel electrode is very similar to this. I can quickly show you what it looks like. You can take your time to figure this out. Yeah, but calomel is something called Hg2Cl2. I think we won't do this. I think this is like a little extra information. मैं आप यहाँ पे slides पे डाल दिया. If you want me to discuss it, let me know. I can do that. But the process is exactly the same. The difference is you got 4 things now instead of 3 things. You got 4 things. And you got 3 phase boundaries. थोड़ा इसको expand करो. The derivation is exactly the same. ठीक है? खैर, anyway, I know थोड़ा ज़्यादा हो गया, and we'll leave it at that. If you guys have time, I strongly suggest this. Please try this out. This question is awesome. ये वाला तो हमने कर लिया था. कौन सा दूसरा सवाल था? Please try this question out as homework. Hg2Cl2, yeah, Rohit. बट जरूरत नहीं है, कैलम इलेक्ट्रो जबरदस्ती कोचिंग में पढ़ाते हैं, बट यू डोंट नीड इट पर से फॉर जेईई नीट राइट नाउ, इवन फॉर जेईई एडवांस यू डोंट नीड इट, बट करना चाहो तो फन में मैंने आपको दिखा दिया, आप लोग कर देना. आई थिंक वील जस्ट skip it. In our next session, we are not going to do Caramel Electrode. We will continue next session from here. Please give me the answer to this homework question. ये भी PYQ ही है, I think. JEE का ही PYQ है. The reason I am doing JEE questions for NEET folks and vice versa is I strongly believe that the content is exactly the same for JEE and NEET. What is different is the kind of question. And don't worry, I'm going to do tutorial session अलग-अलग करूंगा मैं. NEET और JEE के अलग-अलग सेशन करूंगा. जैसे ही मैं इलेक्ट्रोकेमिस्ट्री खत्म करता हूँ, अभी 3 हो गए ना, 3-4 क्लास और बाकी है, जैसे मैं खत्म करता हूँ, I'm going to bring awesome practice session for you separately. JEE के लिए, NEET के लिए, using the app, using Aakash BYJU'S app. It has practice sessions. It's wonderful. ठीक है, उसके थ्रू करेंगे. चलो, thank you so much for your time. If you like, 8:30 बजे आज शाम को I'm going to be starting periodic table. Tell your friends in 11th standard on the JEE channel. I'm going to continue meeting you here on the NEET channel to continue this Electrochem virus series. Also, Electrochem series, funny. ऑल्सो मंडे को आई एम गोइंग टू डू नेक्स्ट 2021 का पेपर, अगर कोई नेक्स्ट का एग्जाम दे रहा है तो. एंड एज यू गाइज वांटेड, नेक्स्ट के मैं कुछ सवाल सेशन 1, कुछ सवाल सेशन 2 दोनों के कर रहा हूं, बिकॉज कुछ लोग बोले यार सेशन 2 इज मोर डिफिकल्ट, बट सिलेबस कम हो गया ना, तो विल डू दैट. चलो, यू नो इट. गुलशन बता दो, प्लीज टेल अस द आंसर इन द कमेंट्स. जैसे ही वीडियो खत्म होता है कमेंट में डालो, यू आर ऑसम गुलशन. यस प्रीतम, प्लीज बताओ इसको. ऑलराइट, सी यू ऑल, हैव एन ऑसम सैटरडे. अगर आना है तो पीरियडिक में भी आ जाना, टाइम पास करने 8:30 बजे. गुड नाइट, सी यू, टाटा.